Hello, my name is Mr. Fallen, and in this video we're going to be looking at problems 22 through 28, which are the last 7 problems of section 10.1 in module 5. All right, so now that I got the giggles out, let's go ahead and do this problem. So this problem is similar to a few of the problems that we looked at in the last video, except that they're decimal numbers. And I'm sorry for the poor handwriting here. Um, what we're going to want to do before we start trying to get rid of q from one side of the equation and moving it to the other side is we need to simplify the left-hand side first. And so we have two terms here with a q. We have 5.5q and we have the minus 5.6q. And those need to be combined together before we start bringing this 1.1q over here, right? We don't want to bring it into a mess like this. So let's simplify this first. 5.5 minus 5.6 is going to be 0.1. So you might use a calculator to confirm that. And also, pardon me, it'll be negative, right? Because 5.5 is positive, 5.6 is negative. That's slightly bigger, so we'll get a slightly negative number here. And the variable part, q, just gets copied down. What we don't have to do here is we don't have to add the 5.6q over to the 5.5q because they are both already on the left-hand side of this equation. So we can combine them together, just ignoring the negative 4.5 that's in the middle, since they're already both on the left-hand side of the equation. I mean, what makes that possible is that the, math, algebra, I shouldn't say just math, but just these terms are commutative. They can be moved around and we can put them in whatever order we want. So the 5.5q and the minus 5.6q can be brought together. So we're not going to bother writing that out, but that's the math behind it that makes that possible. So we just combine them together as if the minus 5 point, sorry, I said the wrong thing. We combine them together as if the minus 4.5 is not even there. So 5.5q minus 5.6q is negative 0.1q. We'll just copy down the minus 4.5 because it's not doing anything. And we'll copy down the equal sign. And there's nothing to simplify on the right-hand side, but if there was, we would go ahead and do that now as well. So since there's nothing to simplify, we'll just copy this down. Minus or negative 1.1q minus 3.6. Now we're dealing with a structured equation that we've seen multiple times already. We want to get q by itself on one side of the equation, so we'll get rid of it from the right-hand side. To cancel out this negative 1.1q, we will add a 1.1q to that. That's going to cancel it out. If we add that to the right-hand side, we have to add the same thing to the left-hand side. And just like happens on every other problem in section 10.1, combining these together is going to give us 1q. Right? Negative 0.1 is negative, plus 1.1 is just equal to 1. And then the q just gets copied down. We'll go ahead and copy down the minus 4.5. And we'll copy down the equal sign and the negative 3.6, right? Which now becomes, well, it was minus 3.6. It now becomes negative 3.6. All right. Now to isolate q to get q by itself, we want to get rid of the negative 4.5. And so we'll do that by adding 4.5. That'll cancel it out. We do the same thing to the right-hand side to balance that out. And since I'm running out of room, I'll just write it over here to the right-hand side. We have 1q, which we can just write as q, right? 1 times q is just q. The 4.5's cancel out. We copy over the equal sign, and then we have negative 3.6 plus 4.5, which is going to equal 0.9. It'll be positive, right? Because this time the bigger number is the positive number. 4.5 minus 3.6, which is going to be 0.9 or 0.9. So that'll be the solution for number 22 in this particular case. All right, let's take a look at number 23. I'm doing terrible in this video. I'm just gonna keep marching forward. We just gotta get this done one way or the other. So this time we have a bunch of fractions. Now this is very lamentable because there is actually a really easy trick for getting rid of all these fractions, but we haven't officially introduced the concept yet to be able to use that trick. So we'll learn about that probably in section 10.2 or 10.3. We're going to learn a way of just eliminating all the fractions that are in your equation so you don't even have to deal with them. But at this point, we don't have the tools available to do that, so we're just going to be stuck dealing with these fractions. So before we start moving terms from one side of the equation to the other, let's make sure both sides are simplified. The left-hand side, there's nothing we can really do here. We have these two terms. One of them has an x, one of them doesn't, so they're not like terms, so I can't combine these together. So I can't simplify these. So I'm just going to copy them down. But on the right-hand side, we have the 3/7 here, and then another 3/7 over here, which can be combined together. Now, even though there's a term in between the two, that doesn't block us from combining these together. We don't need to subtract the 3/7 over to this 3/7 here because they're already both together on the right-hand side of the equation. And we can just move things around so that these can go ahead and be combined together. So we can just add them together as if the minus 2/3 x is not there. So we have 3/7 plus 3/7. This is made much easier by the fact that they already have a common denominator. So the denominator will stay a 7. And we'll add the numerators. 3 plus 3 gives me 6. And then I'm just going to copy down the minus 2/3 x. Right? We ignored it for combining these two terms together, but it's still there, and we still need to copy it down. All right. Now that we've simplified the right-hand side to the best of our ability, let's go ahead and proceed with the usual, which is we have to get x on one side of the equation. So I want to get rid of it from the right-hand side. I can get rid of this minus 2/3 x by adding a 2/3 x. That'll cancel it out from the right-hand side, but to balance out the equation, I have to do the same thing to the left-hand side. So I'll have to add a 2/3 x over here. Again, they're being very nice by giving us fractions that already have a common denominator. So we have 1/3 plus 2/3. The common denominator is 3, so it'll stay a 3. And we'll add the numerators, 1 plus 2, which is also 3. The variable part just gets copied down. We'll copy down the plus 1/4 equals, and don't forget the 6/7. We got to copy that down as well. All right. Now 3/3 can be simplified to 1. Right? 3 divided by 3 is equal to 1. So that's going to become a 1x, which is just x. And we want to get that x by itself by eliminating the plus 1/4. And so we can accomplish that by subtracting 1/4. Right? That'll cancel out the plus 1/4. If we do that to the left-hand side, we have to do the same thing to the right-hand side. And so what we end up with, I'm going to try to continue over here in this space if I can. We end up with 1x. 3/3 is 1. The 1/4 cancel out. We have the equal sign, and then we'll have 6/7 minus 1/4. Now, if those were just plain old numbers that, whole numbers that we're used to dealing with, we would just combine those together. If it was 5 minus 2, we'd say, okay, that's just 3. That's what we want to do here, but because they're fractions, we're going to have to slow down and take our time with it. To subtract fractions, we have to get a common denominator first. So with 7 and 4, the common denominator is going to be 28. So the least common denominator is going to be 28. To make these fractions have that denominator, I will have to multiply. To the 7, I'll have to multiply by 4. Right? 7 times 4 is going to make that a 28. But if I multiply a 4 to the bottom, I have to multiply a 4 to the top. So I get 6 times 4 on top, which is 24. For the second fraction, to make this a 28, I have a 4 here already. To make it a 28, I have to multiply by 7. So I have to do the same thing to the top, multiply 7 to the top. So on the bottom, we'll have 4 times 7, which is 28. On the top, we'll have 1 times 7, which is going to be 7. And we're still subtracting them, so copy down the minus sign. Let's copy down the rest of everything, copy down the equals to. 1 times x is just x. I'm just going to copy that down as x. So now that we have a common denominator, we can subtract these two fractions. The denominator will stay the same. It'll stay 28. And we'll have 24 minus 7, which is going to be 17. And then try to reduce your fraction. Anytime your answer is a fraction, you should try to reduce it. But 17/28 doesn't reduce, so thankfully, we're done. All right, so that was a doozy of a problem. My suspicion is that that's not the last of the fractions that we're going to see. So let's take a look at the next example and see if we got some more fractions to deal with. All right, so this will be number 24. And oh, I was wrong. Okay. Maybe we'll see some fractions before the end, but this one at least doesn't have fractions. This one, though, has parentheses, so that's a new obstacle for us to deal with. We have 5y plus 4 in parentheses minus 2 plus 4y in parentheses equals 4. So we want to solve this equation, which, as always, with all of these equations that we're doing, ultimately means we want to have y equals some number, right? That's our goal, to get y by itself on one side of the equation. A nice thing about this is that we have two y's in this equation, but they're already on the same side of the equation, so that's a benefit. But we still need to get it down to just one y by itself. Before I can combine these y's together, since they're already on the same side of the equation, I don't need to move it or eliminate it from one side and get it to move to the other side. They're already both on the left-hand side of the equation. All I have to do is combine them together. But before I can accomplish that, I have to get rid of these parentheses first. Now, the first set of parentheses is doing nothing mathematically speaking. It's just 5y plus 4. There's nothing for me to distribute. There's no exponent here for me to apply. And so mathematically speaking, these parentheses were pointless. So I'm just going to copy this down, 5y plus 4. I was about to say is rewrite. I'm going to rewrite this 5y plus 4, but without the parentheses because there's no purpose for them. I'd like to do the same thing here, but this set of parentheses actually is serving a mathematical function. It's holding out the minus sign. It's keeping the minus sign away from these terms. So if I want to get rid of the parentheses, the minus sign needs to be applied first. So we want to subtract the 2, but we also want to subtract the 4y. So we need to distribute the minus sign. If it makes you feel better about distributing to have a number involved, there's an invisible 1 here. So it's what we're really distributing here is a negative 1. So we're going to get negative 1 times 2, which is going to be negative 2, and then negative 1 times 4y. Since it's a positive, negative times a positive will make this negative also. And then 1 times 4 is still going to be 4. And the y just gets copied down. All right, so that minus sign has to be distributed. The effect that it has is it changes the sign of each term inside the parentheses. These terms were both positive. Now they're both negative. Right. And then the equals 4, we're just going to copy that down. But once we've distributed the minus sign, the parentheses are no longer necessary, so I stop writing them. I don't copy the parentheses down here because there's no mathematical purpose for them once I've distributed the negative sign or the minus sign. So with the parentheses out of the way, I can go ahead and simplify the left-hand side, clean things up over here. I have a 5y and I have a minus 4y. These are like terms, and even though there's a couple of numbers in the way in between the two of them, because they're already both on the left-hand side, I can just ignore those. I just combine these together, as if the 4 and the 2 aren't even there. We get 5y minus 4y, which is 1y, right? 5 minus 4 is 1. You do not need to add the 4y to bring it over here to the 5y because they're already both on the left-hand side of the equation. They're already together, even though there's a couple terms in between the two. We can always rearrange those terms, and so we can have them side by side. So rather than writing it out that way, we just acknowledge that fact that these can be brought together because they're already on the left-hand side of the equation together, and we just go ahead and combine them together. 5y minus 4y is 1y. We do the same thing with the terms that don't have a variable. 4 minus 2, those are like terms, so we combine those together. Positive 4 minus 2 is going to be positive 2. And then we're going to copy down the equals, copy down the 4 over here. And now this is an equation exactly like ones that we've dealt with in the past. We know exactly what to do here. We want to get this y by itself. To do that, we need to cancel out the plus 2 by subtracting 2. That cancels out the 2's. If I do that to the left-hand side, do the same thing to the right-hand side. And so we end up getting, let's get rid of I said the equal sign for some reason. Get rid of the question mark. 1y is just y, right? 1 times y is just y. Copy down the equals 2, and then we get 4 minus 2, which is going to be 2. All right. So that's question number 24. So now my prediction is we're going to see a few more equations with parentheses rather than fractions. And maybe they'll hit us with a fraction and parentheses problem at the very end. So let's see if I'm right. All right, yep, so more parentheses. So for number 25, we have 2 times b plus 2 in parentheses minus parentheses 8 plus b equals negative 5. Be careful about that. It's easy to overlook that minus sign there because it kind of blends in with the equal sign. So a lot of students don't pick up on that. So be very careful to notice that detail, right? It's a negative 5. So make sure you bring that down here. So just like in the last example, just like in number 24, we want to combine these b's together into a single b, right? My ultimate goal here is to get b equals some number. So I don't want 2 b's in the equation. I just want to have 1 b. But before I can combine these b's together, I need to get rid of the parentheses. The parentheses are trapping the b's, and they're trapping them so that they can't interact with one another. So let's get rid of the parentheses. But before, you can't just erase them. I can't just erase the parentheses and make them not there. I have to get rid of the reason they're here in the first place. And for the first set of parentheses, its mathematical function at the moment is holding out this 2. So before I can erase these parentheses, I need to carry out this mathematical purpose here, which is to distribute the 2, to multiply by 2 to everything inside the parentheses. So in other words, distribute. I need to distribute the 2 into the parentheses, and then the parentheses are no longer necessary, so I can stop writing them. So I'll have 2 times b, which is just going to be 2b, plus 2 times 2, which is going to be 4. Once I've carried that out, the parentheses are no longer needed, so I stop writing those parentheses. We do the same thing with the second set of parentheses. I can't just erase them. I have to acknowledge, or I don't know, I'm having trouble thinking the right words. I have to perform its mathematical purpose first before I can erase them. And in this case, the mathematical purpose of these parentheses is to hold out this minus sign. So before I can get rid of these parentheses, I have to carry out that minus sign, which means I have to distribute it into the parentheses. I want to subtract the 8, but I also want to subtract the positive b. So subtracting b gives me minus b. If you feel better distributing with having a number here, you can think of this as a 1. This is like having a negative 1. Negative 1 times 8 is going to be negative 8. Negative 1 times b is going to be negative b. The equals 2 gets copied down, the minus 5 gets copied down. Now that the parentheses are out of our way, we can combine like terms. So we have 2b, that's one term here on the left-hand side, and then minus b, which is also on the left-hand side of the equation. So everything over here is already together on the left-hand side of the equation. So we don't need to add the b over to the 2b to join those together. They're already together on the left-hand side of the equation. So we can just combine them together as if nothing was in between them. So we have 2b minus 1b, if you want to put a number with that, which is going to be 1b. Right? 2 minus 1 is equal to 1. The b just gets copied down. Here we have 4 minus 8. These two things are like terms, this here and this here. Combine those together, and we get 4 minus 8, which is negative 4. Copy down the equal sign, copy down the minus 5. Now to get b by itself, we want to get rid of the minus 4. We do that by adding 4 to both sides of the equation. Right, we add 4 to cancel out the minus 4. To balance that out, we also have to add 4 to the right-hand side. 1 times b is just equal to b. We copy down the equal sign, and we simplify the right-hand side here. Negative 5 plus 4 is going to be negative 1. And so we get our solution of b equals negative 1. All right, let's take a look at the next example, which is number 26. So more parentheses. So we have negative 9 times 2b plus 3 plus parentheses 19b minus 7 equals 0. All right. Okay. So to proceed with solving this equation, we want to get these b's combined together. before I can make that happen, I have to get rid of the parentheses that are blocking me from combining the b's together. To get rid of this set of parentheses, I have to perform the mathematical operation that is making the parentheses necessary in the first place. So why do I have this set of parentheses here? Mathematically speaking, it's to multiply it by this -9, or to distribute the -9 into the parentheses. Same thing. So to multiply this parentheses by -9, we'll go ahead and distribute. And once I've distributed, the parentheses are no longer mathematically necessary, so I can just drop them. I don't need to write them anymore. So I'm going to have -9 times 2b. Now, whenever you're multiplying a number to a term like this, what I always like to say is you multiply together what goes together. So the -9 and the 2 go together. I can multiply those together and I get -9 times 2, which is going to be -18. And then the variable part just gets copied down because nothing's getting multiplied to it. We just copy it down. And then we'll have -9 times +3. Negative times a positive will be negative. And then I don't have to worry about the signs at that point, right? I've dealt with the signs. Negative times a positive is negative. Now I just deal with the numbers. 9 times 3 is going to be 27. And I don't need to write the parentheses anymore because there's no mathematical purpose for them any longer. For this set of parentheses, they throw these parentheses in here, but it's really sort of a trick because these parentheses aren't serving a mathematical purpose to begin with. There's nothing for me to distribute into the parentheses. I'm not raising it to any power, so these parentheses really serve no purpose whatsoever. So I can just erase them essentially. I can just drop them without having to do anything mathematical. So this is just going to be 19b minus 7, and I just don't write the parentheses with that. And then I'll copy down the equals 0. Now that the parentheses are out of the way, I can go ahead and combine these terms together, simplify the left-hand side. I have -18b plus 19b. Because they're already both on the same side of the equation, I don't need to subtract the 19b to bring it over here to the -18b. They're already together on the left-hand side. I can just go ahead and combine them together. -18 plus 19 is going to be 1. And then the variable part just gets copied down. Same thing with the numbers here. Even though they seem separated from one another, they're already together on the left-hand side of the equation. I can just combine them together as if there's nothing in between them. -27 minus 7, again, this one's negative and this one's negative, so be careful about that. It's going to be minus 34. And then I'm just going to copy down the equals, copy down the 0. Now I want to get b by itself. To do that, I need to get rid of this minus 34. I can cancel it out by adding a 34. That's going to cancel that out. But if I do that to the left-hand side, I have to do the same thing to the right-hand side. So I'm going to get 1b, which is just b. The 34's cancel out. Copy down the equal sign. 0 plus 34 is going to be 34. And that'll be my solution. All right, 2 more problems to go. So let's take a look at number 27. If we're lucky, we won't see any more fractions. Let's see what happens here. Okay, no fractions in this one. That's good. All right, so number 27, we have 7 times, parentheses, -3x plus 1 equals -20 times, parentheses, x plus 1. Now, we've seen a few problems with parentheses already, but those parentheses were all on the same side of the equation. This problem's a little bit different because we have parentheses. We have one on the left-hand side of the equation and one on the right-hand side of the equation. So what we've done in the past when we have x on both sides of the equation is I want to get rid of it from one side and have it moved over to the other side. We want to do the same thing here, but I can't make that happen while this x is stuck inside of this parentheses. So we have to get rid of the parentheses first before we can start moving things around from one side of the equation to the other. To get rid of the parentheses, I'm not allowed to just erase them from the equation. I have to consider their mathematical purpose first. So the reason this set of parentheses is here on the right-hand side of the equation is it's holding out this -20. So if I want to get rid of the parentheses, I have to get rid of the reason it's here, which is holding out the -20, which means I need to go ahead and distribute the -20 into the parentheses so that it's no longer outside the parentheses. And once it's no longer outside the parentheses, I don't need the parentheses anymore. I can just get rid of them. Right, so I'll go ahead and do that here. I'm going to have negative 20 times x. Negative 20 times x will just be negative 20x. And then I'm going to have negative 20 times positive 1, which will be negative 20. Right? Negative 20 times 1 is negative 20. And now that I've distributed into the parentheses, I don't need to keep parentheses here, because sometimes I'll have students that they'll say, okay, I'll go ahead and put the parentheses around this. And that's not wrong mathematically, but it's just unnecessary. There's no reason for these parentheses anymore, and it's just going to cause you grief later on. So don't continue to write the parentheses if there's no mathematical purpose for them any longer. Right. So let's go ahead and put this 20 back here and put the equals back here. Okay, we got to do the same thing on the left-hand side. There's no reason to bring this minus 20x over to the left-hand side while there's a parentheses here, blocking us from combining anything together. So we need to get rid of these parentheses also by distributing the 7. So I'm going to get 7 times negative 3x. That's going to be negative 21x. And then I'll get 7 times positive 1, which will be positive 7. And again, stop writing the parentheses once you get rid of the reason for the parentheses to be there in the first place. So I'm sorry if I haven't been saying that very well in this video, but that's kind of the point I've been trying to make. Now, I want to get x by itself on one side of the equation. Every problem we've done in the last couple of videos, we've gotten rid of x from the right-hand side and have it on the left-hand side instead. In this case, if I do that, if I say, okay, let's get rid of the x on the right-hand side by adding a 20x here, I'll have to do the same thing to the left-hand side. But I can see what's going to happen here is I'm not going to end up with just x by itself, but I'll have negative 1x, which is to say just negative x. But I'll have that negative sign in front of the x, which is going to be annoying. And again, we haven't really talked about what to do about a negative sign in front of x. We're going to talk about that in section 10.2. So I'd rather just avoid having the negative sign in front of the x if I can. And that can be avoided here by going the other direction. Instead of getting rid of x from the right-hand side, let's get rid of x from the left-hand side. To cancel out the minus 21x here, or the negative 21x, I will add a 21x. That'll cancel out the negative 21x. So these will cancel out. If I do that to the left-hand side, I do the same thing to the right-hand side. And just thinking ahead a couple of steps, I can see that when I combine these together, I will get positive 1x. And that's going to be nicer than having negative 1x, right? That way I don't have the negative sign to deal with. So while it's a little bit unconventional, it works out better in the end if I can avoid having a negative sign in front of my x. So I'll copy down the positive 7. Copy down the equals 2. We already combined these together. We get 1x from that. And then I'll copy down the minus 20. All right, now I want to get this x by itself on the right-hand side. To do that, I need to get rid of the minus 20. To get rid of the minus 20, I'll add 20. That'll cancel out the minus 20. If I do that to the right-hand side, got to do the same thing to the left-hand side. So the minus 20 and the plus 20 cancel out. We'll have just 1x on the right-hand side, which I can just write as x, right? 1 times x is just x. I'll copy down the equals to 7 plus 20 is going to be 27. Again, the minus 20 and the plus 20 cancel out. So this is all we're left with, which is my solution. X is equal to 27. So 27 equals x is the same thing as x equals 27. And that's the answer I'm looking for. All right, last problem. Let's take a look at this one. Hopefully it's not too crazy. And it's not too bad. There's 3 parentheses instead of just 2 like we've been dealing with, but we'll deal with it in the same way. We have negative 3 times 4p plus 4 minus 2 times, parentheses, 1 minus 11p equals 3 times 7 plus 3p. So the issue that we've been dealing with in these last several examples is I'm not going to be able to move these terms around or combine these p's together while there's parentheses blocking us from doing that, right? The parentheses really they're kind of like a prison, right? So our terms are stuck inside of these parentheses and they can't communicate with the other terms in the other parentheses. So we need to get rid of these parentheses before we can start moving things around and combining things together. To get rid of the parentheses, we have to get rid of the reason the parentheses are here in the first place. So this first set of parentheses is serving the mathematical purpose of holding out this negative 3. So if I want to get rid of these parentheses, I need to distribute the negative 3 into the parentheses first. All right, so we get negative 3 times 4p. Negative times a positive will be negative. And then here you multiply together what goes together. So 3 times 4 go together to give me 12. And then the variable part just gets copied down because it doesn't have anything to multiply to. Then we multiply the negative 3 to the positive 4. Negative times a positive will be negative. And then 3 times 4 is going to be 12. And now that we've distributed the negative 3, the parentheses no longer serve a mathematical function, so we don't need to write them here anymore. So we just drop the parentheses at that point. We do the same thing here. We want to distribute the 2 into the parentheses. But this one you have to be careful about because the minus sign has to go with it. Right? So when I distribute the 2, I need to bring the negative sign along with that. So I'm really distributing a negative 2. So I'm going to get negative 2 times 1. Negative 2 times 1 is going to be negative 2. And then I'll have negative 2 times negative 11p. Negative times a negative will be positive. And then you multiply together what goes together. 2 times 11 will be 22. And then the variable part has nothing to multiply to, so we just copy it down. And then lastly, to get rid of this last set of parentheses, we'll need to go ahead and distribute the 3. 3 times 7 will be 21. 3 times 3p will be 9p. 3 times 3 is 9. P gets copied down. Before we start moving things from one side of the equation to the other, we need to simplify what we're dealing with over here. So on the left-hand side, we'll combine like terms. We have negative 12p plus 22p. These are like terms, and we can combine those together. Negative 12 plus 22 is going to be 10, positive 10. The variable part just gets copied down. So we just copy down the p. And then these two terms are like terms. Negative 12 minus 2 combined together to give me negative 14. So I'll write a minus 14 there. Equals 21 plus 9p. All right. Now I want to get rid of the variable from one side of the equation so that it only exists on the other side. So I know that maybe I'm not saying that very well, but it's been a long video, so my brain's kind of fried at this point. So I want to get rid of p from the right-hand side. I can get rid of the 9p by subtracting 9p, right? It's a positive 9p, so I subtract 9p to cancel it out. If I do that to the right-hand side, I have to do the same thing to the left-hand side. So we get 10p minus 9p, which is going to be 1p, minus 14 equals 21. So to get p by itself, I need to get rid of the minus 14. I can cancel that out by adding 14. Cancels out the 14s. If I do that to the left-hand side, I have to do the same thing to the right-hand side. So I'll write the answer over here. We have 1p, which I'm just going to write as p. The 14s cancel out. Copy over the equal sign. 21 plus 14 is going to be 35. So p is equal to 35. All right, that does it for section 10.1. Hope you were able to make it through that okay. And I'll see you in section 10.2.